All right, so we are going to start section 7.5, which is special types of linear systems. So for the first 4 sections of chapter 7, we went through all different types of solving systems and talking about how each type of system had just one solution and how we were solving for each type of system and getting that one answer and how we would write that as a point. Well, now in section 7.5, we're going to talk about how sometimes that's not always the case. Sometimes you can have some special situations. So, what we're going to do is we're going to practice graphing, since that's what we've been doing in this entire section. And we're going to go through and see what happens when we graph certain linear systems. So we have a linear system. We have 2x plus y equals 4 and 4x minus 2y equals 0. So throughout this entire video, I'm going to ask you guys 5 questions. Your homework assignment is going to be to answer those 5 questions throughout this video. So what I'll be looking for in class tomorrow is the answers to those 5 questions. So question number 1. When I graph these lines, what's going to happen? Or what do you think will happen? Okay, so remember, we're going back to that cover up, right, where you want to cover up both the x and the y. Okay, so we're going to first take line 1, and I'm going to make that our red line. So we're going to find our x-intercept. And I am writing horrible, so I'm going to get something to write with. So let's just erase that. I am not a great video maker. Alright, so we're going to make this our red line. Okay, we're going to make it a little bit thicker as well. Actually, let's make it our green line. Okay, so that's our green line. So we're going to first find our x-intercept. Okay, so if you guys remember, we're going to cover up our y value. So we're going to have 2x equals 4. So we're going to divide by 2. Therefore, x equals 2. Okay, so we're going to go over to our x-axis and we're going to make our point at 2. Now we're lucky with our y-intercept. When we cover that up, we just get y equals 4. So we're going to go up to 4 and make our point, and we're going to connect those. Okay, now the problem with our second line, which is here, if we were to do our x and y intercepts, you'll notice that they both come out to 0. Okay, and if you were to make a point, 2 points at 0, you don't know what line you're going to have. You could go this way or this way or this way. So unfortunately, what we have to do is we have to rearrange that. Okay, so what we're going to do is we're going to rearrange that into y equals mx plus b form. So we're going to start by rewriting that. So we have 4x minus 2y equals 0. We're going to subtract our 4x to both sides. So we have negative 2y equals negative 4x plus 0. And then we're going to divide by a negative 2. So we have y equals, and I apologize, my dogs are making noise. We're going to have negative 4 divided by negative 2, which is positive 2x plus 0. So remember, this is your y-intercept, and this is your slope. Okay, so we're kind of practicing some old versions of graphing. So we're going to start at 0. That's our y-intercept. And then we're going to use our slope. We're going to go up 2 and then over 1 and up 2 and over 1. up to and over 1. Okay, and that's your line. So that question 1 that I asked, what happens when you graph the lines? So you're noticing right now what happens when you graph those lines? Okay. We have one solution. And I can't spell. So we have one solution. Because they intersect, they cross. Okay? So that's one type of linear system that we've already talked about. Well, what else happens? Okay? So that's what we want to talk about. What are these special types of linear systems? All right, so let's talk about those. Another type of linear system. So our next example, what we're going to do is we're going to do the same thing, except we're going to use our intercepts once again. This time we get to use intercepts for both of them. So again, we're going to have our green line. Okay, so we have our x-intercept and our y-intercept. Okay, x-intercept, we have 2x equals 5. So x is 2.5. And then our y-intercept is just going to be y equals 5. So x is 2.5. So that's in between 2 and 3. And then y is 5. So we make our line. Our second line we'll make blue. So we have our x-intercept and our y-intercept. So for question 2, as I'm drawing these lines, what do you notice about the two equations? Okay, is there anything that you notice about these two equations right here? Okay, and you're going to notice something really, really special about these lines in 1 second. So we have 2x equals 1. And then y equals 1. So I'm going to graph y equals 1. And then 2x equals 1. We're going to divide by 2. That gives us x equals 1/2. And when we graph that, what do you notice about those lines? That's not a perfect line, but what do you notice about them? Do they cross? What are they? They are parallel lines. Okay, so do you think that has anything to do with those equations? Okay, what do those look like and why are they parallel? Okay, so now we have 2. Our first, they cross. We have an answer. Here, they don't cross, they're parallel. So, let's see what our next. So now we have another system. And we're going to do the same thing. We're going to graph using our intercepts. So again, we have our green line and our blue line. Okay, so green line, we have our x-intercept and our y-intercept. So 3x equals -1 and y equals -1. So when we divide by 3, x is -1/3. Remember, when you're graphing your intercepts, it's okay to have intercepts as fractions because sometimes those answers don't come out as fractions. So x equals -1/3. That's between 0 and -1. Okay, nothing's ever going to be perfect. And then y is -1. So we can graph those lines. Okay, my lines are not perfectly straight. You guys can see that. All right, and our next line, our x-intercept, we have -9x equals 3. And then our y-intercept, -3y equals 3. So when we divide -9 and -3, okay, so x equals 3 divided by -9, and if we reduce 3 over -9, we actually get -1/3. That's interesting. I feel like I just saw that number, and I actually did right here. Interesting. And then y, 3 divided by -3 is -1. And again, I feel like I just saw that, and I did right there. So I'm going to plot those points again and make that same line. And what do you notice here? Okay, so this is question 3. What do you notice about this line? Or these lines? I should say these lines. It just gave you a hint. What do you notice? What makes them so special? Okay, so now, how can we do this algebraically without having to graph? So, if we look at an equation, we want to recognize that there might be something common between those two equations before we graph them. So, if you notice, is there a relationship between this x and this -2x? Think about how we were trying to solve this using elimination. Was there a number that we could maybe multiply by x to get it to be the same as that -2? So for your fourth question, what number should you multiply that top equation by? Okay, so I'm going to show you how to solve it graphically, and then we'll talk about it algebraically. So again, using your intercepts, x is going to be 5. Y will be -2.5. And then x will be -1 for that second equation. And y will be 1/2. And you notice that we get parallel lines. Okay, so if we go back to talk about numbers that we could maybe multiply, if we multiplied 2 times that top equation, we'd get 2x minus 4y equal to 10. And the bottom equation would stay the same. So -2x plus 4y equals 2. So if you were to try and solve this, a +2 and a -2, they're going to cancel. A -4 and a +4, they're going to cancel. We have nothing left on the left-hand side. On the right-hand side, we're adding 10 and 2. That's 12. Does this work? No. Therefore, this is no solution. Okay, so we talked about how that first example, way back at the beginning of this video, when you have two lines that cross, that's going to give you an answer. Well, these lines don't cross, they're parallel. And when we solve this algebraically, this gives us no solution. Okay, well, what about that time where we had those two lines that were one on top of the other? What does that mean? So we were just talking about the system where you had a line on top of a line, and we talked about how when we had graphed this, we saw that the 2 points were exactly the same. So we had seen that earlier. Well, what exactly does that mean? So if we look at our 2 lines, we see that we have 3x plus y equals -1, and negative 9x minus 3y equals 3. So, is there some kind of relationship between 3 and 9? Well, if you notice, you can take 3 and multiply that by 3. If you multiply 3 times 3, that's going to give you 9, which is exactly the number in the bottom equation. So we're going to end up with 9x. Up at the top, we're going to have 3y. So we have 9x plus 3y, and that's going to equal a -3. The second equation, we don't have to do anything. We're going to have -9x and -3y and a +3. If you take a look at everything, you're going to notice that our x's, we have a +9x and a -9x. A positive and a -9, that's going to cancel. A +3y and a -3y, that's going to cancel. We have nothing on the left side. We have 0. It's equal to our right side, where we have a -3 and a +3. What happens there? They cancel. We have nothing. Well, when is 0 equal to 0? That's right, 0 is equal to 0 all of the time. So, what makes this so special is that this is when we have what we call infinite many solutions. So, many solutions. Okay, what that means is no matter what number you substitute into this equation, it's always going to work on this line. These 2 lines are multiples of each other. The second is a multiple of the first. Okay, so when you get 0 equal to 0, that means many solutions. So I want to recap with you guys to just talk about the 3 different types of systems that we talked about today. So the first is something that we have talked about many times before. Okay, this is when we get one solution. So when you get one solution, that means that you're going to have 2 lines that intersect at a particular point. Okay, and that's going to be your answer, your solution. Okay, so that's when we have one solution. We've talked about that for 4 sections now. All right, that's not anything new. Our new things are our no solution. No solution is when those 2 lines do not cross. They're parallel lines. They're never ever going to meet. They're never ever going to see each other. They're like 2 lines in the middle of a road, never ever crossing. Okay? 2 lines in the middle of a road, 2 sides of a door, they're never going to cross. No solution. They have no points in common. And the final one, which is the one everybody likes, is many solutions. Okay, it's a line on top of a line. Okay, so you can have multiple equations that share that same exact points. Okay, so those are our 3 different types. So for a recap, the 5 questions that I'd like you to answer. Number 1, what happens when you graph the lines in the first example that we went over? The first example that we went over was 2x plus y equals 4, and 4x minus 2y equals 0. So what happened when we graphed those lines? If you have to, you can always rewind the video. Number 2, what do you notice about the equations in the second system? So the second system that we went over was 2x plus y equals 5 and 2x plus y equals 1. So what did you notice about those equations? We talked about that. Number 3, when we graphed the equations in our third system, what do you think that they would look like? In that third system was 3x plus y equals -1 and -9x minus 3y equals 3. We talked about that twice. And number 4, for the example that we went over on your own, though I helped you, what number do you think you should have multiplied with? Again, the on your own example was 2x plus y equals nope, I'm sorry, I'm reading the wrong one. X minus 2y equals 5, and -2x plus 4y equals 2. And the last question, total opinion question, but try and make me feel good, is did you enjoy watching the video? I know this is a first video for me, but I want to see how, if you guys enjoyed that, because we can always do some more of these. So, let me know what you think, and answer these 5 questions. It's not too difficult for you guys to do, and we are going to talk about this in class tomorrow. Thanks. Bye, guys.